Hello everyone, welcome back to Husky Math. In this video, we'll learn about maxima and minima, which is one of the most important application of derivatives. So using derivatives, we can find the highest or lowest value of a given function, okay? So which helps us solve many practical problems like involving the problem involving maximum profit, minimum cost, or the shortest distance, and many more, okay? So here's I made a function here. So as you can see that at point A the function has some maximum value, and point C also the function has maximum value, and at point B we have some minimum value, and at point D also we have some minimum values. So these are called the local maxima and local minimas. See here, the point A, B, C, D are called the critical points because as you can see at point A, the function has been increasing and again started decreasing from point A. So this point A, B and C and D are called the critical points. And A and C are the points of local maximum. If you see that at point A and point C, the function has the highest points, and these are called the local maximum, okay? And why the term is local maximum? Because around the neighborhood of A, the maximum value of the function is exactly at A. That's why the point A is called the point of local maximum. At C also, if you see, then at the neighborhood of C, the function is a little bit lesser than at the point C. So point C is called the point of local maximum, and the corresponding values like FA and this FC are called the local maximum values, and similarly point B and D are called points of local minimum. If you see here at point B, the function has been decreasing and again started increasing, okay? So at point B we are getting the least value of the function, and similarly at point D also we are getting some smaller values of the function around its neighborhood of D. So, and the corresponding values FB and FD are called the local minimum value, okay? Between point A and C, the function is maximum at point C. So this value at C, which is FC, is called the absolute maximum value. That means this is the maximum of all other local maximum. And similarly, if you see at point B and point D, the function has some minimum values, that is local minimum values, but between these two minimum values also, at point B, the function has the lowest value. That's why the point B is called the absolute minimum value. Here's a note: a local minimum can be greater than local maximum, because the point D is the point of local minimum and point A is the point of local maximum. But if you compare then between FA and FD also, the FD, which is local minimum value, is greater than the local maximum value at A, that is FA. So how to use the derivatives in order to find the maxima and minima? For that, if you see at point C, the function is increasing at first and decreasing afterwards. That means if I make a tangent or before C, then the slope of the tangent will be positive, and if I make a point after C and make a tangent there, then the slope of this tangent will be negative. That means using derivatives we can say that if the derivative is positive at first and derivative is negative afterwards, then we can say that the point C is the point of local maximum. Similarly, point D is the point of local minimum. In graph we can see it clearly. At the point before D, if I make a tangent before D, then the slope of the tangent will be negative, and after D, if I make a slope there, then the slope of this tangent will be positive again. That means before D, the tangent of the function is negative, and after that it is positive. So whenever the derivative is negative first and afterwards positive, that means that point will be the point of local minimum. So this is how we use the concept of derivatives to find the point of local maximum and local minimum. So in order to find the point of local maximum and minimum, we have the first derivative test. So we will follow these steps. So first we will differentiate the given function and equate with 0, then we will get some values, and those values are called the critical points, and those points will be the local maximum or local minimum point. Okay, and we have to check the sign whether the f dash x is positive or negative, and based on that, if f dash x changes from positive to negative, that means if the function is increasing at first and decreasing afterwards, then that point through which this is happening is called the point of local maximum. And similarly, if f dash x changes from negative to positive, that means the function is first decreasing and afterwards increasing. That means if this is happening through the point C, then that point C is called point of local minimum. And if f dash of x does not change sign, that means before C or after C, if sign remains same, then that point C is called point of inflection. So let's begin with some questions. Question number 1, we have to find the points of local maxima and local minima, and based on that we have to find the local maximum value and local minimum values, and the given function is here. So first we will differentiate the given function. So differentiating both sides with respect to x, I'll have f dash of x equals to 5x to the power 4 minus 20x cube plus 15x square. So we will put this f dash of x equals to 0 in order to find the critical points. This implies 5x to the power 4 minus 20x cube plus 15x square equals to 0. Taking out 5x square common, we will have x square minus 4x plus 3 equals to 0. Now let us factorize, then we will get x minus 3, x minus 1 equals to 0. Now from here we will get the values of x as 0, 3 and 1. So let us make our real number line and mark 0, 1 and 3. Let us pick 1 points from each interval and let us put that values in f dash of x. Let us pick minus 1 from here, from this interval, and if I put minus 1 here in this f dash of x, then I'll have minus x square, which will be positive, minus 1 and minus 3 will be negative, minus 1 and minus 1 will be negative. So positive into negative is positive. So in this interval I'll get the value of f dash of x as positive. So here I'll get the positive value. Now let us choose any point between 0 to 1. So let us choose 0.5 from here and let us put it here, 0.5 here, then it will be positive. 0.5 minus 3 will be negative. 0.5 minus 1 will also be negative. So here's negative times positive, which is again positive. So between 0 to 1 also the value of f dash x is positive. Now let us choose any point between 1 and 3, then let us choose 2 from there, and if I put 2 in f dash of x, then I'll get 2 square, which is positive, 2 minus 3 which is negative, 2 minus 1 which is positive. So here's positive into positive is negative. That means the function f dash x will be negative between 1 and 3. Now let us choose another point more than 3 and let that be 4, and let us put it here, then it will be 4 square, which is positive, 4 minus 3 is positive, 4 minus 1 is again positive. So here's positive times positive is positive. That means in this interval the f dash x is positive. So it is clear that the function is increasing, and after 1 it is decreasing, and after 3 it is again increasing. That means it is clear that this point 1 is the point of local maxima, point 3 is the point of local minima, and there is no change before 0. After 0 the sign of f dash x remains positive to positive. That means point 0 is the point of inflection. This is neither the point of local maxima, neither the point of local minima. So here x equals to 1 is a point of local maxima, x equals to 3 is a point of local minima, and x equals to 0 is a point of inflection. So this is one part of question. Now we have to find the local maximum values and local minimum values. For that, we have to put the value of x equals to 1 in the given function in order to find the local maximum values. So therefore, local maximum value is f of 1, putting the value of x equals to 1. So this will be equal to, so we have to put the value of 1 in the given function, then it will be 1 to the power 5 minus 5 into 1 to the power 4 plus 5 into 1 cube minus 1, and that will be 1 minus 5 plus 5 minus 1, which is equals to 0. So 0 is the local maximum value. Similarly, the local minimum value is f of 3, because 3 is a point of local minima. So let us put the value of 3 in the given function, then we will have 3 to the power 5 minus 5 into 3 to the power 4 plus 5 into 3 cube minus 1. And on solving all these values, we will get minus 28, which is the local minimum value. Second derivative test. This is another method to find the value of local maxima and local minima. So here's we will differentiate the given function 2 times. So at first we will differentiate the given function and find the value of f dash of x, and equating it with 0 we will find the critical points, and again we will differentiate the f dash x, so we will get f double dash of x, and whatever the critical points we will get, we will put it here and we will get the value of f double dash of c. Now if the value of f double dash c is negative, then that c is called the point of local maximum, and if f double dash of c is greater than 0, then that c is called the point of local minimum, and if f dash of c is equal to 0, then we have to go back to the first derivative test. So these things you have to copy in your formula book or wherever you want to. So let us find the point of local maximum and local minimum using second derivative test. So here's the given function. Let us first differentiate the given function here. So here it will be f dash of x equals to 6x square minus 42x plus 36. Now let us differentiate again with respect to x, then we will get f double dash of x equals to 12x minus 42. Now in order to find the critical points, we have to put f dash of x equals to 0 as usual. So here it will be 6x square minus 42x plus 36 equals to 0. Taking out 6 common, we will have x square minus 7x plus 6 equals to 0. And on factorizing the quadratic polynomial, we will get x minus 6 into x minus 1 equals to 0. So from here we will get critical points as 1 and 6. Now we have to put this value of x, 1 and 6 in f double dash of x. So when x equals to 1, then f double dash of 1 will be equal to 12 into 1 minus 42. See, we are putting the value of x equals to 1 in f double dash of x here. So it will be equal to 12 minus 42, which is equal to minus 30, and this is less than 0. That means if this value is less than 0, then this x equals to 1 is the point of local maximum. Similarly, let us put the value of x equals to 6 in f double dash of x, then we will get f double dash of 6 equals to 12 into 6 minus 42, which will be equal to 72 minus 42, and this is 30, which is a positive number. Now since f double dash of 6 is coming positive, that means x equals to 6 is the point of local minimum. Now in order to find the corresponding local minimum values and local minimum values, we put the value of x equals to 1 and 6 in the given function, that is here. Therefore, the maximum value is when x equals to 1, that is f of 1, and f of 1 will be equal to 2 into 1 cube minus 21 into 1 square plus 36 into 1 minus 20, and on simplifying we will get this as minus 3, which is the maximum value. And similarly, the minimum value is when x equals to 6, that is f of 6, and f of 6 will be equal to 2 into 6 cube minus 21 6 square plus 36 into 6 minus 20, which is equal to minus 128. So here let me repeat for you. In the second order derivative test, we will differentiate the given function 2 times. So we will get the values of f dash of x and f double dash of x. And in order to find the critical points, we have to equate f dash of x with equal to 0. And from there we will get the critical points. Now this critical points we have to put in f double dash of x in order to check whether those points are point of local maxima or local minima. And after confirming the points which is local maxima and local minima, we will put those values in the given function, that is f of x, in order to find the values of local maxima and local minima. Question 3. So that the maximum value of 1 by x to the power x is e to the power 1 by e. So let us assume the given function as f of x. So let fx equals to 1 by x whole to the power x. So before differentiating, let me write 1 by x as x to the power minus 1 whole to the power x. So my function fx equals to x to the power minus x. Now let us take a logarithm both sides, then we will have log of f of x equals to log of x to the power minus x. So this implies log of f of x equals to minus x log of x. Now we will differentiate both sides with respect to x. Then we will have ddx of log of fx will be 1 by f of x, and by the chain rule we have to differentiate f of x, that will be f dash of x equals to, let us use product rule here, keeping x differentiating log of x plus keeping log of x differentiating x. That means the value of f dash of x will be equal to minus f of x into 1 plus log of x. Now let us again differentiate both sides with respect to x. Then we will have f double dash of x equals to minus, let us use product rule again, let us keep f of x and differentiate 1 plus log x, then it will be 1 by x, plus keeping 1 plus log x first and differentiating f of x, I'll get f dash of x. So here we were using the product rule. Okay, so f dash of x will be equal to minus f of x over x minus 1 plus log of x into f dash of x. So here we have got the value of f dash of x and we got the value of f double dash x also. Now in order to find the critical point, we have to put f dash of x equals to 0. So let us put f dash of x equals to 0, then I'll have minus f of x into 1 plus log of x equals to 0. Now since fx is an exponential function, as you can see here, fx is an exponential function, so this cannot be equal to 0. So here I'll have 1 plus log of x equals to 0, and from here I'll get log of x equals to minus 1, and since this is a natural logarithm, so I'll have x equals to e to the power minus 1, that is x equals to 1 by e. This x equals to 1 by e is my critical point. Now we will put this x equals to 1 by e in f double dash of x. So let us put this x equals to 1 by e here in x, that is f double dash of 1 by e. Then I'll have f double dash of 1 by e equals to minus f of 1 by e divided by 1 by e minus 1 plus log of 1 by e into f dash of 1 by e will be 0, because we got the value of x equals to 1 by e by putting f dash of x equals to 0. So if I put back the value of x equals to 1 by e in f dash of x, then this will obviously be 0. Okay, so this implies f dash double dash of 1 by e equals to minus e into f of 1 by e, and this is less than 0, because as you see, this e is an exponential function and f of 1 by e is also an exponential function, because fx is an exponential function. So that means these two are both positive, and since there is a minus sign, so this will be negative. That means x equals to 1 by e is my point of local maximum. Therefore, x equals to 1 by e is the point of local maximum. And in order to get the maximum value, we have to put this x equals to 1 by e in the given function, that is fx equals to 1 by x whole to the power x. Therefore, the maximum value is equals to f of 1 by e, and this will be equal to 1 over e whole to the power 1 by e. So this will be equal to e to the power 1 by e, and hence the question was asking to prove the maximum value is e to the power 1 by e. Question number 4. The given function is fx equals to sine to the power 4x plus cos to the power 4x, and here we have to note that x lies between 0 to pi over 2. So let us differentiate both sides with respect to x. Then I'll have f dash of x equals to 4 sine cube of x into, with chain rule, ddx of sine x is cos x, plus ddx of cos to the power 4x will be 4 cos cube x into ddx of cos x is minus sine x. So my f dash of x will be equal to, let us take out 4 sine x cos x common, then I'll have sine square x minus cos square x inside the bracket. So this implies f dash of x equals to, so here we can write this 4 as 2 into 2 sine x cos x, and let us take out minus common from here, then we will have cos square x minus sine square x. So f dash of x will be equal to 2 into 2 sine x cos x is sine 2x, and let us write minus in front, and cos square x minus sine square x is cos 2x. Therefore, f dash of x equals to minus, now see here, 2 sine theta cos theta is again sine 2 theta, hence I'll have this everything as sine 2 theta, that is 2 into 2x. Therefore, f dash of x is minus sine of 4x. Now let us differentiate again both sides with respect to x. Then I'll have f double dash of x equals to minus 4 cos of 4x. Now in order to get the critical points, we have to put f dash of x equals to 0. So put f dash of x equals to 0, then I'll have minus sine 4x equals to 0, and this implies sine 4x equals to 0. Now this particular angle 4x can be 0, or it can be pi, or it can be 2 pi, it can be 3 pi, it can be 4 pi. So it can take any values of n pi. But we have to also notice that this x lies between 0 to pi by 2, and this is only possible when this 4x is equal to pi. So from here we got the value of x as pi by 4, which is our critical point. Now let us put this critical point in f double dash of x. Therefore f double dash of pi by 4 will be equal to minus 4 cos 4 into pi by 4. So we have 4 and 4 got cancelled, and we know that cos pi is minus 1. So it will be equal to minus 4 into cos pi is minus 1. So this will be equal to plus 4, which is greater than 0. That means this x equals to pi by 4 is the point of local minimum. Therefore x equals to pi by 4 is the point of local minimum, and the local minimum value is, we have to put this critical point or this point of local minimum in the given function, that is f of x. So my answer will be f of pi by 4, and this will be equal to sine to the power 4 of pi by 4 plus cos to the power 4 of pi over 4. So this will be equal to 1 by root 2 whole to the power 4 plus 1 by root 2 whole to the power 4. So this will be equal to 1 by 4 plus 1 by 4. So this will be equal to 2 by 4, and hence the local minimum value at x equals to pi by 4 is 1 by 2. Question 5. Find the maximum profit that a company can make if the profit function is given by p of x equals to 41 plus 24x minus 18x square. So we have to maximize the profit. That means we have to maximize the given function. So my given function px equals to 41 plus 24x minus 18x square. As usual, we will differentiate this 2 times. So first of all, I'll differentiate and I'll get p dash of x equals to 24 minus 36x, and again differentiating, I'll get p double dash of x, and that will be equal to minus 36. Now in order to get the critical point, we will put p dash of x equals to 0. So from here I'll get 24 minus 36x equals to 0. So this gives 36x equals to 24, and hence the value of x equals to 24 by 36, which is 2 by 3. So this x equals to 2 by 3 is my critical point, and this could be the point of local maximum or the point of local minimum. But in this type of question, where the question is saying to find the maximum profit, that means this critical point 2 equals to 3 is the point of local maximum only. So you can skip the part of showing that this point is point of local maximum. You can directly say that this point is the point of local maximum, and you can directly get the maximum profit by putting this value in the given function px. But still, let us try to check whether this point is the point of local maximum or not. For that, we have to put this 2 by 3 in p double dash of x, and if I try to find the value of p double dash of 2 by 3, and that will be minus 36 only, and which is less than 0. So therefore this 2 by 3 is the point of local maximum. It is confirmed, and the maximum value is p of 2 by 3. So here x equals to 2 by 3 is the point of local maximum, and the maximum profit is equal to p of 2 by 3. So let us put the values here. It will be 41 plus 24 times 2 by 3 minus 18 into 2 by 3 whole square. 3 1s are 3, 3 8s are 24, equals to 41 plus 16 minus 18 into 4 by 9. So 9 ones are 9, 9 twos are 18. This will be equal to 57 minus 2 fours are 8, and the maximum profit that a company can make is 49. Question 6. An enemy jet is flying along the curve y equals to x square plus 2. A soldier is placed at the point 3, 2. Find the nearest point between the soldier and the enemy jet. So here is a curve on which an enemy jet is flying, and the equation of this curve is given as y equals to x square plus 2. Now, since the jet is flying on this route and a soldier is placed at a point 3, 2. So let 3, 2 be our point S. Now we have to find the nearest point between the soldier and the enemy jet. So for that, the distance of this point from this curve should be minimum. So let that minimum distance be here, this much. And we have to find the nearest point. That means we have to find this particular point. Let us name it as P. So let the coordinate of P be x comma y, which can be written as x comma, since we know the value of y is x square plus 2. So we have to find the value of P here, but we have to minimize the distance, that is SP. We have to minimize this particular distance. So here we have to minimize the distance SP, and we know from the distance formula the distance between any two points is given by square root of x2 minus x1 whole square plus y2 minus y1 whole square. So here if I use that formula, then I'll have x minus 3 whole square plus x square plus 2 minus 2 whole square. See here, my x1 y1 I consider this point, and x2 y2 I consider 3, 2. So here 2 and 2 got cancelled. So let us square both sides, then I'll have sp square equals to x minus 3 whole square plus x square is x to the power 4. And let us consider this function as f of x. Now since we got the function f of x, we have to minimize this fx. Now as usual, we will differentiate fx 2 times. So here differentiating fx 2 times, then I'll have f dash of x equals to 2 into x minus 3 into dtx of x minus 3 is 1 plus 4x cube. Now let us again differentiate this both sides with respect to x, then I'll have 2 into dtx of x minus 3 is again 1 plus 12x square. So f double dash of x equals to 2 plus 12x square. Now in order to find the critical point, let us put f dash x equals to 0. So put f dash of x equals to 0, then I'll have 2 into x minus 3 plus 4x cube equals to 0. So this is a cubic equation, so we will get 4x cube plus 2x minus 6 equals to 0. So this implies taking 2 common, then we will have 2x cube plus x minus 3 equals to 0. Now in order to factorize, we will use the trial and error method at first. So if I put x equals to 1 here, then it will be 2 plus 1 minus 3, and that will satisfy this equation. That means if I put the value of x equals to 1 here, this is satisfying the equation. That means x minus 1 is a factor of this equation. Then we can rewrite this equation as 2x square into x minus 1, because 2x square into x is 2x cube, but here minus 2x square is the extra part. So to balance that, I will have to add 2x and multiply with x minus 1. So in this way the 2x square part will get balanced, but there is minus 2x, but since we have got plus x only, so we'll plus 3 and multiply x minus 1 equals to 0. So this is the way how you factorize the cubic equation. For that you need to know by yourself. Okay, if you don't know, then you can learn how to factorize a cubic equation. So here on factorizing, we will have x minus 1 times 2x square plus 2x plus 3 equals to 0. So from here in the second part, as you can see, there is a quadratic equation, but this quadratic equation cannot be solved to a real values, because if you try to solve this part, then you will get imaginary numbers, which we do not want here. So that means we will only consider x minus 1 equals to 0, and from there I'll get the value of x as 1. Now this 1 is a critical point, which could be point of local minimum or point of local maximum, but since the question is saying that we have to find the nearest point, that means we have to minimize, that means this x equals to 1 will be the local minimum. For that you can put this x equals to 1 in f double dash of x and check. So here if I put f x equals to 1 in f double dash of x, then I'll get f double dash of 1 will be equal to 2 plus 12, which is equal to 14, and this is greater than 0. That means x equals to 1 is confirmed as the point of local minimum. Therefore x equals to 1 is the point of local minimum. And here we will not find the minimum values. Okay, we just need to find the coordinates of point P, and whose coordinates are x comma x square plus 2. Now since we got the value of x equals to 1, so we will put it here, and on doing so I'll get the point as 1 comma 1 square plus 2. This will be equal to 1 comma 3. That means my required answer for this question is 1 comma 3. That means 1 comma 3 is that point on the route of the enemy jet which is nearest to the soldier who is placed at point 3 comma 2. Find the two numbers whose sum is 16 and whose cubes is minimum. So let the two numbers be x and the other number be 16 minus x, because their sum should be 16. So the question is saying that their sum of their cube should be minimum. So let us cube the first number, then I'll get x cube, and cubing the second number I'll get 16 minus x whole cube, and their sum should be minimum. And let us assume this as f of x. So my question becomes now to minimize this f of x. For that we have to differentiate both sides with respect to x. Then we will have 3x square plus 3 16 minus x whole square, and differentiation of 16 minus x is minus 1. So my f dash of x equals to 3x square minus 3 into 16 minus x whole square. Now let us differentiate again. Then we will have f double dash of x equals to 6x minus 6 into 16 minus x, and derivative of 16 minus x is again minus 1. So here it will be plus. Now in order to find the critical points, let us put f dash of x equals to 0. So this implies 3x square minus 3 times 16 minus x whole square equals to 0. So here if I open this bracket, then it will be 16 square is 256 minus 32x plus x square equals to 0. So I'll have 3x square minus 768 plus 96x minus 3x square equals to 0. So here 3x square and 3x square got cancelled. So I'll have minus 768 plus 96x equals to 0. and on simplifying I'll get 96x equals to 768, and this implies x equals to 8. Now this 8 is the point of local maximum or local minimum. So for that, let us find the value of f double dash of 8, which will be equal to 6 into 8 plus 6 into 16 minus 8, and if you simplify you will get this as 96, which will be greater than 0. That means x equals to 8 is a point of local minimum. That means this x should be 8 if the sum of cubes of those two numbers should be minimum. That means my first number is 8 and the second number is 16 minus 8 equals to 8. That means my two numbers are 8 and 8. Question 8. A window is in the form of a rectangle surmounted by a semicircular opening. So first let us make the shape of the window according to the question. So here's the shape of a window according to the question. There is a rectangle at bottom and on top of it there is a semicircular opening. The question is saying that the total perimeter of the window is 10 meter and we have to find the dimensions of the window to admit maximum light through it. So in order to admit maximum light through the window, the area of the window should be maximum. So here first of all let us write, we have to maximize the area of window. But the condition is given that the perimeter of the window should be 10 meter. So at first let us assume the dimensions of the window. Since there is a semicircle, so let us assume the radius of the semicircle to be r. That means the diameter of the circle or semicircle is 2r, and which is the length of the rectangle here. So here the length of the rectangle will be 2r because the radius of the semicircle is assumed to be r, and let the breadth of the rectangle be simply b. So b is from here to here, and on the other side also there is b. Okay. Now since the question has given that the total perimeter of the window is 10 meter, so here the perimeter of the window means the length, which is 2r. We have to add b, we have to add the semicircle perimeter of this circle, and we have to add again b. So this total length is given 10 meter. So here since perimeter is given 10 meter, and here we have to find the perimeter as, let us add this length, that is b, plus this length, that is 2r, plus b, plus the perimeter of a semicircle is given by pi r. Because the perimeter of a full circle is 2 pi r, so the perimeter of the semicircle, that means this much length, is pi into r. So plus pi r equals to 10. So from here we will get 2b plus 2 plus pi r equals to 10, and hence from here 2b equals to 10 minus 2 plus pi r, and hence the value of b is 10 minus 2 plus pi r whole divided by 2. Now let us try to write the area of this window. See, there are two shapes, that is rectangle and a semicircle. So the area of this window will be area of rectangle plus area of semicircle. So here area of the window is area of rectangle, which is length into breadth, and since length is 2r and breadth is b, so this is the area of rectangle, plus we have to add the area of semicircle. We know the area of circle is pi r square, that means the area of semicircle will be pi r square by 2, the half of it. So now here as you see, this area is depending on the value of r and b. But since there are two variables, so we will try to replace the value of b from here. That's why we got the value of B earlier. So my area will be 2R into 10 minus 2 plus pi R over 2 plus pi R square by 2. So let us take the LCM here, then here it will be 2 and we will get 2R into 10 minus 2 plus pi into R plus pi R square. So that means the area will be 1 by 2 into 20R minus 2 into 2 plus pi R square plus pi R square. Now if you simplify this everything, you will get the value of A as 1 by 2 into 20R minus pi plus 4 R square. Now here A is a function of R and we have to maximize the area of the window. That means we have to maximize this A. So likewise we will differentiate this equation 2 times with respect to R. So let us differentiate both sides with respect to R. Then we will have ddr of A, I will write A dash equals to half is constant, ddr of 20R is 20 minus pi by 4, pi plus 4 is constant, and ddr of R square is 2 times R. Again differentiating, I will get A double dash equals to half into minus 2 into pi plus 4, and here 2 and 2 got cancelled, so I'll have A double dash as minus pi plus 4. Now to get the critical point, let us put A dash equals to 0, then I'll have 1 by 2 into 20 minus 2 into pi plus 4R equals to 0. So from here, if you simplify and try to get the value of R, then you'll get R equals to 10 by pi plus 4. This point will be the point of local maxima, as we have to maximize the given area. And also, since A double dash is just minus of a number, that means A double dash is already negative and which is less than 0. So this R equals to 10 over pi plus 4 is the point of local minima. And the question was asking to find the dimensions of the window. So since R is our radius of the circle, that means the radius of this semicircle should be 10 by pi plus 4 unit. Therefore length of the rectangle should be, since in the figure the length is 2R, so it will be 2 into 10 by pi plus of R, which will be equal to 20 by pi plus 4. And breadth of the rectangle should be, since the equation of breadth is 10 minus 2 plus pi R by 2, so we will use this equation. So it will be 10 minus 2 plus pi into the value of R is 10 by pi plus 4 whole divided by 2. So if we simplify this, then we will have 2 into pi plus 4 at denominator, and here in numerator we will have 10 into pi plus 4 minus 10 into 2 plus pi. So this equals to 10 pi plus 40 minus 20 minus 10 pi over 2 into pi plus 4. So here 10 pi and minus 10 pi got cancelled. So this equals to 40 minus 20 is 20 by 2 into pi plus 4, and hence the breadth should be 10 by pi plus 4. So the dimension of the window should be that the length should be 20 by pi plus 4 unit and breadth should be 10 by pi plus 4 unit, And of course, the radius of the semicircle should be 10 by pi plus 4 unit. Question 9. Prove that the volume of the largest cone that can be inscribed in a sphere is 8 by 27 of the volume of the sphere. So let us make a diagram for this. So here's a sphere whose radius I have considered as capital letter R, and inside this sphere I have adjusted a cone of largest volume, okay, and I have assumed the height of the cone to be h and radius of the cone be small letter r. So here I have to maximize the volume of the cone because it is saying that volume of the largest cone. So here first thing I have to note is that volume of the cone has to be maximized, and we know that the volume of the cone is 1 by 3 pi r square h. Now since we have to maximize this volume of the cone, but since here there are two variables, small letter r and h, which are the radius of the cone and height of the cone, so we try to substitute the value of r and h in terms of known values from the figure, okay. So here let us look at the figure. If capital R is the radius of the sphere, then this particular length should also be R. So here this is also capital letter R. And similarly, if I join this center of the sphere up to this point, then this length also should be capital letter R because that is also the radius of the sphere. And let us assume this particular length to be x. So let this length be x. Now looking at the figure, I can write that the value of height of the cone can be written as capital letter R plus x. See here, this entire length is the height of the cone, and this height of the cone is equals to R plus x. So that I have written. And if you notice here, I can see a right angle triangle, and in this right angle triangle, this capital R is the hypotenuse, small letter r is the base, and x is the perpendicular. So by Pythagoras theorem, here also we can write x square plus base square equals to hypotenuse square. So here I can write small letter r square as capital R square minus x square. Now since I have got the value of h as r plus x and the value of r square as capital R square minus x square, we will substitute these two values here in the volume of the cone. So by doing so, my volume of the cone can be written as 1 by 3 pi small letter r square means capital R square minus x square into h means r plus of x. Now one thing is to note that this is a given sphere and radius whatever we have assumed is capital R. This is to be treated as constant. That means here in the formula of volume of the cone, the variable is only x and this r is to be treated as constant. So, and since we have to maximize the volume of the cone, so before differentiating v with respect to x, let us simplify this equation further. So here I can write v equals to 1 by 3 pi. This is in the form of a square plus b square, so I can write as r plus x into r minus x into r plus x. So then my volume of the cone can be written as 1 by 3 pi r plus x whole square into r minus x. So this is the given function. Now we will differentiate v both sides with respect to x. And note that capital R is constant here. So differentiating both sides with respect to x, then I will get dv over dx equals to 1 by 3 pi is constant. And using the product rule, let us keep r plus x square first and differentiate r minus x, then I will get minus 1 plus keeping r minus x constant, differentiating r plus x whole square, we will get 2 into r plus x and ddx of r plus x is 1, since we are differentiating with respect to x. So dv over dx equals to 1 by 3 pi minus r plus x whole square plus 2 into r plus x into r minus x. So let us take out r plus x common, then we will have minus r plus x plus 2 times r minus x equals to 1 by 3 pi r plus x into minus r minus x plus 2r minus 2x. So this will be equal to 1 by 3 pi r plus x into r minus 3x. So this is the first derivative, that is, this is f dash of x. Now here, in order to find the critical point, we will equate dv over dx with 0. So putting dv over dx equals to 0, we will have 1 by 3 pi r plus x into r minus 3x equals to 0. Now from here we will get the two values of x, that is x equals to minus r and x equals to r by 3. And obviously we will not consider this minus r because length cannot be negative. That means x equals to r by 3 is the critical point, and this could be the point of local minimum or local maximum. But since the question was asking to maximize the volume of the cone, so this x equals to r by 3 is the point of local maximum only. Okay, you can check by double differentiating the given function and putting x equals to r by 3 there also. Okay, but I am not doing so because now I know that the volume of the cone will be maximum when x equals to r by 3. So now I will try to find the volume of the cone or the maximum volume of the cone. Now let us put the value of x r by 3 here, because volume of the cone is given in this equation in terms of x. Maximum volume of the cone will be 1 by 3 pi r plus, let us replace x with r by 3 whole square r minus r by 3. So this equals to 1 by 3 pi. So here it will be 4r by 3 whole square into 2r by 3. And on simplifying we will get 1 by 3 pi into 16r square by 9 into 2r by 3. So this equals to 1 by 3 pi into 16 2s are 32 r cube by 27. Now this is the volume of the cone, and we have to show that this volume of the cone, which is maximum, is 8 by 27 of the volume of the sphere. For that we should know the volume of the sphere also. We know that volume of sphere is given by 4 by 3 pi r cube, and since the radius of the sphere was r, so it will be like this. Now let us find the ratio of volume of cone is to volume of sphere. Then it will be equal to 1 by 3 pi 32 r cube by 27 whole divided by 4 by 3 pi r cube. So here 3 and 3 got cancelled, pi and pi got cancelled, r cube and r cube also got cancelled, and 4 1s are 4, 4 8s are 32. That means volume of cone over volume of sphere equals to 8 by 27, and hence the volume of cone is equal to 8 by 27 times the volume of sphere. Question 10. A wire of length 36 cm is cut into two pieces. One of the pieces is turned in the form of a square and the other in the form of an equilateral triangle. Find the length of each piece so that the sum of the areas of two should be minimum. So there's a wire of length 36 cm and this wire has been cut into two pieces. Let that be x and the other be 36 minus x because total length is 36. Now from this first piece of wire a square is formed, and from the second piece of wire an equilateral triangle is formed. So the question is asking the length of each piece such that the area of this square and the area of this equilateral triangle in total should be minimum. So let us assume the length of this square to be A and the length of each side of this equilateral triangle be B. So here the perimeter of this square is 4 times A and this 4 times A should be equal to x because this square is made from the piece of wire which is x centimeter long. That's why the total length of the square should be x, and similarly the perimeter of this triangle should be equal to 36 minus x because this triangle is formed from this 36 minus x centimeter piece of wire. So here the perimeter of the rectangle is b plus b plus b, that is 3b should be equal to 36 minus x. So from here we got the value of A as x by 4 and from here we got the value of B as 36 minus x by 3. Now the question is saying to minimize the area of these two. So the sum of areas of these two figures will be, let the total area be A. So area of square is side square plus area of equilateral triangle is root 3 by 4 side square, and since my side is B so it will be B square. Now let us put the value of A and B here, so it will be x square by 16 plus root 3 by 4 into B square means 36 minus x whole square by 9. So the area of the figures will be x square by 16 plus root 3 by 4 into 9 is 36 and 36 minus x whole square. So I have to minimize this area. That means my function is ready. So let us differentiate a both sides with respect to x. Then I'll have dA over dx equals to 2x over 16 plus root 3 by 16 into 2 times 36 minus x, and by the chain rule derivative of 36 minus x will be minus 1. So here 2 1s are 2, 2 8s are 16, this is 2 and this is 18. So dA over dx will be equal to x by 8 is minus root 3 by 18 into 36 minus x. Now we are interested in finding the minimum value of x. So to find the critical point we will put dA over dx equal to 0. On doing so I'll get x by 8 minus root 3 by 18 into 36 minus x equals to 0, and this implies x by 8 equals to root 3 by 18 into 36 minus x. So here let us cancel, 2 4s are 8, 2 9s are 18. So it will be, on cross multiplying we will get 9x equals to 4 root 3 into 36 minus x implies 9x equals to 144 root 3 minus 4 root 3 x. So it will be 9x plus 4 root 3 of x equals to 144 root 3. Therefore, the value of x will be 144 root 3 divided by 9 plus 4 root 3. So this should be the length of wire from which we are making a square. So this is my one part of answer. So the other length is 36 minus x. So let us calculate the value of 36 minus x. Then it will be 36 minus 144 root 3 by 9 plus 4 root 3. On doing so, I'll get 9 plus 4 root 3 as LCM, and in numerator we will have 324 plus 144 root 3 minus 144 root 3. So the other part will be 324 by 9 plus 4 root 3. So the length of the other piece will be 324 over 9 plus 4 root 3. So this is the required answer. Number 11, show that of all the rectangles of a given area, the square has the smallest perimeter. Let us assume the length of the rectangle be L and breadth be B. And the question is saying that a rectangle will be a square if it has to be of smallest perimeter. If you know this or not, that square is also a rectangle, a special type of rectangle where length and breadth are equal. So here the given area is fixed. So we know that area of a rectangle is given as length into breadth. So from here let us take out the value of B as A by L. So here in this question we will considering the area of the rectangle to be constant. So here my capital A is constant where L and B are variables, and the question is saying that the perimeter of this rectangle should be smallest. Okay, and that means we have to minimize the perimeter. So let us write the formula for the perimeter of a rectangle, and we know that perimeter of a rectangle is given as 2 times length plus breadth. So that means P equals to 2 into L plus, now instead of B from this equation I can write A by L. Now see, my function is ready where P is a function of L, where A is a constant, and we have to minimize this P. So we will differentiate this P with respect to L. So differentiating both sides with respect to L, then we will have dP over dL equals to 2 into ddL of L will be 1 plus A into ddL of 1 by L is minus 1 by L square. So that means dP over dL will be equal to 2 times 1 minus A by L square. Now in order to find the critical point, we always put the first derivative as 0. So here we will put dP by dL equals to 0. On doing so, I'll have 2 into 1 minus A by L square equals to 0. So therefore A by L square will be equal to 1, and hence L square will be equal to A, and the value of L will be equal to square root of A, neglecting the negative value. So that means if the perimeter of this rectangle should be small, then the length should be square root of A. Now let us try to find the breadth of the rectangle by putting this value in this equation. Then we will have B equals to A by L, which means B equals to A by putting the value of L as root A. So here it will be A by root A. Now rationalizing the denominator, we will get B equals to A root A by root A times root A is A. So here A and A got cancelled, and my breadth is also root A. Now here if you notice, then if the perimeter of this rectangle should be small, then length should be root A, B also should be square root of A. That means length and breadth are both coming root A, and if length and breadth are equal, that means this rectangle is a square. Question 12. Find the maximum and minimum values of the given function on the closed interval 0, 3. So whenever the interval is given closed, then we have to check the value of the function at 0 and 3 also, as well as on the point of local maxima or minima. So as usual, let us assume the given function to be 3x to the power 4 minus 8x cube plus 12x square minus 48x plus 25, and let us differentiate both sides with respect to x. Then I'll have 12x cube minus 24x square plus 24x minus 48, and let us again differentiate. Then we will give 36x minus 48x plus 24. Now in order to find the critical point, let us put f dash of x equals to 0. Then we will have 12x cube minus 24x square plus 24x minus 48 equals to 0. Taking out 12 common and simplifying, we will get x cube minus 2x square plus 2x minus 4 equals to 0. So let us factorize here by taking x square from these two terms. Then I'll have x minus 2, and 2 from these two terms, taking out common, then I'll have x minus 2 equals to 0. So here we will have x minus 2 times x square plus 2 equals to 0. Now here if you notice that from this x square plus 2 we will get imaginary root, which we will be not requiring. So we will get the real roots from this x minus 2 only. So here from here we get the real values of x as 2 only. So this 2 is the critical point. Now let us put this 2 in f double dash of x here. Then we will have f double dash of 2 equals to 36 times 2 minus 48 into 2 plus 24, which will be equal to 72, and this is greater than 0. That means this x equals to 2 is the point of local minimum. Now my interval was from 0 to 3 and my critical point I have got is 2. Now we will check the value of the function at all these 0, 2 and 3, and from it we will choose the minimum and maximum values. Okay, so here first let us check f of 0. Then we will have, and this is equal to 25. Let us check at 2, which is my point of local minimum, minus 39. And let us check the function at x equals to 3 also, 16. Okay, now out of all these values I am getting the minimum value of the function as minus 39, because my x equals to 2 was the point of local minimum, and the maximum value I am getting is 25 at x equals to 0. So these were my minimum and maximum values. And with that we come to an end of this topic, that is maxima and minima. In this topic we will learn how derivatives help us to find the maximum and minimum values of a function. It was quite a long video, so thank you for staying with me till the end. I'll see you in the next topic. Bye bye.